Hey, welcome to the Sistas channel. I'm Amy. Today we're going to walk you through some key concepts in soil fertility, mainly the nutrients in soil, and these concepts were covered in week 5. Let's get started. Let's talk about one of the most fundamental elements in soil fertility, which is of course nitrogen. So the nitrogen cycle is very complex and has a lot of parts to it, so we recommend drawing out the cycle on your own at least once.
Nitrogen comes in many forms. It can be a gas like N2, it can be a cation like ammonium, it can be an anion like nitrate, or it can be organic nitrogen, which means it's associated with some carbon. When reporting nitrogen concentrations, there's usually two conventions that we follow. First is nitrate or ammonium in milligrams per liter. So for these reporting conditions, you need to know that nitrate is 62 milligrams per millimole and ammonium is 18 milligrams per millimole. And the 62 comes from the molar mass of nitrate and the 18 comes from the molar mass of ammonium. Another way you can report nitrogen concentrations is by using the nitrate N or ammonium N concentration. So this is the amount of nitrogen that's attributed to nitrate or the amount of nitrogen that's attributed to the ammonia. So here 14 milligrams per liter of nitrate nitrogen is the same as 62 milligrams per liter of nitrate. And how we get these numbers is nitrate is 62 milligrams per millimole of molar mass, and nitrogen alone is 14 milligrams per millimole. Here's an example where the soil tested has 40 milligrams per liter of nitrate nitrogen. So the question is, how much nitrate is in that soil? So let's go through this. So 40 milligrams per liter of nitrate nitrogen. Use your conversion factor, which we just went over, that there's 14 milligrams per liter of nitrate nitrogen per 62 milligrams per liter of nitrate. And your answer, you cancel these, your answer is 40 times 62 over 14. Okay, so this is Liebig's law of the minimum, where we want to talk about plant growth factors in terms of essential nutrients or other factors like water availability, air, heat, and light. So imagine we have a barrel and the planks are at different lengths. So the water coming out of the barrel is determined by the smallest plank, which, for example, the smallest plank is the most limiting factor. So our most limiting factor in this particular instance is phosphorus. So if we wanted to increase the phosphorus up to a greater height,
Then the next limiting factor is this next smallest one, which is potassium. But something important to think about is if we see that potassium is the limiting factor and then we increase something like nitrogen, the growth factor won't be changed because potassium is still the limiting factor. So thinking about increasing a factor that isn't limiting, you actually might decrease the growth limiting factor of a plant because it's not the limiting factor.